So first of all, we have a theorem that's called the tangent and intersected chord theorem. Okay, so the tangent and intersected chord theorem is a lot of vocab. Okay, but it doesn't have to be hard. So first of all, remind me, what's a tangent? Segment or line? A line. And what does a tangent do? How does it intersect the circle? At one point, called the point of tangency, right? So a tangent's a line that intersects a circle at exactly one point, called the point of tangency. Only touches a circle in one place. And a chord, line or segment? Segment. A segment that intersects the circle in exactly two places. Okay, the endpoints are on the circle. Okay, so we have a tangent and a chord that are intersecting at the point of tangency. Okay, and there's a relationship between the angles that are formed. So angle 1 is exactly 1/2 of its intercepted arc, of its major arc, CDB. Okay, so if we know the measure of this arc, we divide it by 2, we get the measure of the angle. And this red arc, CB, is the intercepted arc for angle 2. And angle 2 is going to be exactly 1/2 of that intercepted arc. So same thing that we did last time, right? Only before we had angles that were inscribed with their intercepted arc. And this was half of this. This is going to be half of this, and this will be half of this. Okay? So we're just dividing by 2, or multiplying by 2. Make sense? All right, so here we go. M is the tangent to the circle, and we want to find a measure of either the red angle or the red arc. Okay, so here's your first example. We want to know what is the measure of this major arc C through D to B. So what would we have to do? If we have the angle and we're trying to find the arc that it intercepts, what do we have to do? Multiply by 2. So 110 times 2 is 220. 220 degrees. Make sense? Okay, now let's look at the next one. This time we want to find the inscribed angle, right? Or the angle that intercepts the arc. Not really inscribed angle, but this angle. So if we knew its arc, we could find the angle, couldn't we? But we don't know its arc, do we? But how could we find its arc? Okay. Absolutely. A whole circle is 360 degrees. So if we take the circle of 360 minus the 160, we'll have our red arc. And then we have, since we have the red arc, we have to divide it by 2. And we get the angle. Make sense? Questions on this one? Okay, nothing horrible, right? Okay, so let's take the next step. And let's talk about what happens when we intersect things not exactly on the circle, but, well, on the circle, outside the circle, or inside the circle. So if we have two non-parallel lines intersecting a circle, there are those 3 places where they can intersect, either on it, inside it, or outside it. Okay? First, we're going to talk about the inside situation. So when angles are inside the circle, and they're intersecting, 2 chords, two secants, right, are intersecting inside the circle, then the measure of each angle is half the sum of the measures of the arcs that are intercepted by that angle and its vertical angle. So if I want to know angle 1, it is half of the sum of the red arcs. So we're inside the circle, we add big arc plus small arc, and we divide it by 2. Okay? To find angle 2, our blue angle, we find the big blue arc plus the big small arc, and we divide it by 2. So far, so good? Add them up, divide by 2. Inside, you add, divide by 2, and the vertical angle and the angle itself will have the same measure. Make sense? All right, so let's look at the first example of this one. So we want to find x, and the way to remember it is arc plus arc divided by 2. Okay? What's my larger intercepted arc? 104. What's my smaller one? So 104 plus 70, because we're inside the circle, divided by 2 is going to give us 174 divided by 2. What's 174 divided by 2? So 87 is this angle x, and it's also going to be that angle because they're vertical. Okay? Now, they can try and trick you a little bit, make you do a little extra work, because they can say, hey, I want to find y instead. Right? How would we find y if we could figure out that x was 87? You could go that route, or what kind of a line, or what kind of angle do these two form? Or what's their relationship? They're a linear pair that's supplementary, right? So we could take 180 minus the 87 and get our other angle back. Okay, so this could be 93 degrees. So it may ask you, they may ask you in your textbook to just do this straightforward, add them up, divide by 2 to find either of these angles, but they may ask you what's the linear pair to it, the supplement of it. Make sense? Okay, here's the next one. Now we want to know what the smaller arc is. And we're given the larger arc and we're giving the angle measure. Okay? So we still do the same thing, right? They're intersecting inside the circle. So we still add the arcs, divide by 2, and then set them equal to the angle. So if I add these arcs, my big arc plus my little arc, absolutely. You bet. Okay? As a shortcut, Jaden asked, could we just double 67 right away? Absolutely. Okay? We can add them up and divide by 2 and set them equal to 67, but what would be the next step here? How do we solve something like this? Cross multiply, right? So you could just double the angle right away and get 134 is equal to the sum of the two arcs. Does that make sense? As long as you write down what you're doing on your paper, I don't care if you do it this way or this way. You're saving yourself a step less pencil lead. Does that make sense? But show your work. Tell me what you're plugging into your calculators. Okay? So now, how do we solve this for x? Subtract the 85. So 134 minus 85. Yep, 49 degrees. Is that a reasonable answer for our solution? Yeah, it looks like it could be 49 degrees. And how would we check? Well, if we added 49 plus 85 and divided it by 2, we better get our 67 back. Okay? Questions on this slide? When they intersect inside, add, divide by 2. Make sense? Okay, what happens when they intersect outside? So, it does not matter whether it is a secant and a tangent, or two tangents, or two secants. Okay? It does not matter. If our angle is formed outside of the circle, then we have to take the difference of the arcs. Does it make sense to take the small arc minus the big arc? What happens when you do that? You get a negative answer, right? Does that make sense to have a negative angle? Not in our class, right? So we want to take the big arc minus the small arc and divide it by 2 to get our outside angle. Inside we add, outside we subtract. Okay? would be negative. You just have to change the sign. Okay, so if you mess up and subtract the small minus the large, and you get a negative on your calculator, you divide it by 2, you get a negative, you just have to realize, wait a minute, I subtracted the wrong way, and my answer should be positive. Does that make sense? All right, so let's see how this works. So here we've got a secant and a tangent. Here we have two secants. Here we have two tangents. It does not matter how that angle is formed. But the minute you notice that it's outside the circle, that means we're doing what? Subtracting, okay? So we want to take the big arc minus the small arc and divide it by 2. And that's why I capitalized them the way I did, to remind you, big arc minus small arc divided by 2. Okay? So what's my large arc on this first one? And we're subtracting the small one. And then we're going to divide it by 2 to get our angle. So 148 minus 84 is, and 64 divided by 2. So 32 is x. Is that a reasonable answer? Absolutely. It looks like it could be a 32-degree angle, although we can't always go by what it looks like, right? If someone hasn't designed their problems right. Okay, next one. Are we intersecting inside or outside the circle? Is the angle inside or outside? Outside, so we're subtracting. Okay? So we know that the big arc minus the small arc divided by 2 gets us the angle. Should be writing this down, gentlemen. Okay? So our big arc is x. Our small arc is 44. We're subtracting because we're outside the circle. We divide it by 2, or if you want to take the shortcut and just multiply your angle by 2 right away, you can do that. Does not matter either way. So 52 will be equal to x minus 44, so we have to add 44 to both sides. So you get the same answer either way, you just save some pencil lead. But if it confuses you to do that, then set it up the way we have it. Okay? So x will be equal to 96. Yes, question. When we cross multiply here, we're trying to get rid of the dividing by 2. And so 1 times the x minus 44 is 2 times the 26. Okay? So just think about it as having that cross multiply. Okay? All right, so far so good? Okay, here comes the last one of this group. Now, they know that you're intelligent young ladies and men, so they're not going to give you every last piece of information, but they know that you can figure this out. So we have a angle that's been formed outside of the circle, right? And we have what kind of arc? Major or minor? Minor arc, right? But they didn't tell us this major arc, did they? Can we figure out what the major arc is? How would we find it? Exactly. 360 minus 125 gets us 235. So now we subtract, right? Big arc minus little arc. And what do we get when we subtract? Eric. What do we get when we subtract? So focus and pay attention. So big arc minus the little arc divided by 2 gets us our angle. So if we get 110 and we divide that by 2, we get 55. Okay, thank you very much. Okay, so questions on any of these three? Okay, outside we subtract and divide by 2. Insides we add, divide by 2. If there's only one arc, then we divide it by 2, just like our inscribed angles. Okay, all right, here comes the last example. This part I didn't put on your notes sheet because I don't know that it's absolutely necessary, because we can figure it out using the stuff that we already know. So why jumble up our brain with one more theorem? Okay, But first of all, they want you to know what a circumscribed angle is. And a circumscribed angle is an angle whose sides are tangent to the circle. So we take two tangents, we make an angle, and that's called a circumscribed angle. Okay? Circumscribed means it's outside. Okay? We circumscribe a polygon, that means the circle's on the outside of the polygon. Okay? All right, so we have, do you have a pass? So we have a lovely figure like this, and they tell us that this angle is going to be equal to 180 minus its central angle. Remind me, what's the central angle again? Angle that has a vertex that is the center. Okay? That angle and that arc are already the same. So I don't know that we need this particular theorem. Because watch what happens. This first example. What's the measure of its central angle? 127. Okay? So if the measure of its central angle is 127, then what will the 127's intercepted arc be? When you have a central angle that's 127, then the arc that it intercepts is how much? 127, right? The same. This is from 10-2. So these two are the same when it's a central angle only. So far, so good? Okay. So if this is 127, how much is this major arc? 233. How did you get that? Exactly. Now can we figure out what the measure of angle x is? It's outside, so we subtract and divide by 2. 233 minus 127. And we get 106. And 106 divided by 2 is 53. So did we need that other theorem? Maybe, maybe not. Maybe it makes it faster. I don't know. But it's one more thing to put in your brain and try to remember. Okay? And this is stuff that you have to remember come next year when you're taking the ACT. As you saw in the pre-ACT, there was geometry stuff on there. And there will be geometry questions on your ACT as well. And they don't give you the formulas. You have to remember them. Okay? Remember how it works. All right, so this is a challenge problem. We can spend some time on it in just a moment. What I'm going to do is put the assignment up. And if you want to get started right away on the assignment, you can. And if you want to process this for a moment and think about it, let's see what's going to happen here.